my dear students, in this video now we are going to learn about the preparation and properties of the pyridazine. Pyridazine is also known as the 1,2 diazine. Di means 2, azine means nitrogen. So the 6-membered heterocyclic compounds which contain 2 nitrogen atoms in them are called as the diazines. Here 2 nitrogen atoms are present on the first and second portion, so that's why it is called as the 1,2 diazines. Now we go for the preparation methods. Among them, first one is the preparation of the pyridazine by using the Malig anhydride. So the we know the structure of the Malig anhydride very well. So the structure of the Malig anhydride is like this. So this is a Malig anhydride, and when it is treated with the hydrazine, and we know the formula of the hydrazine, that is the NH2 and NH2. So this is the hydrazine, and this is the maleic anhydride. And when this mixture is treated with the HCl in the presence of water, and then after it is treated with the hydrogen in the presence of the palladium coated on the carbon, that means palladized carbon. Okay na? So ultimately here we get the what is that pyridazine derivative or pyridazine compound. Okay, so this is pyridazine. Now we go for the mechanism that involves in this reaction. Okay na? So look here. First of all, maleic acid undergoes hydrolysis. Maleic anhydride undergoes hydrolysis. This is maleic anhydride, no? When maleic acid undergoes hydrolysis, we get the acid, maleic acid. So here we have tried one more COOH, but for convenience we write OH here, ketone group here, and hydroxyl group here. Okay, so this is also what is that, maleic acid. This is maleic acid and this is maleic anhydride, and now it is treated with the, that means this maleic acid reacts with the hydrazine. So look here, one oxygen from here and 2 hydrogens from here go out in the form of the water. Okay na? And one OH from here and H from here goes outside in the form of water. That means the 2 water molecules goes outside, and we get a condensed product like this. Look here. Right, this is condensed product. Now this undergoes tautomerism. So look here, hydrogen goes here and double bond comes here. As a result, right, here we get OH, and here also we get OH. This is known as the 3,6 dihydroxypyridozine. Okay na? Now this is known as the 1, 2, 3, 4, 5, 6. So it is known as the 6-hydroxypyridozine 3-one. Okay. When this 3,6 dihydroxypyridozine is treated with the phosphorus oxychloride, that means POCl3, what is that, we get the 3,6 dichloropyridozine. 3,6 dichloropyridozine. And look at this, on dechlorination with hydrogen gas in the presence of palladized carbon, loses chlorine atom, and we get the, what is that, pyridazine compound. So look at this is Pyridazine. So this is the preparation of the pyridazine by using the maleic anhydride. In maleic anhydride, the two main components are the maleic anhydride and the hydrazine. Okay. Discuss about the second preparation method of the pyridazine, that is by using the 1,4 dicarbonyl compounds. Here as the 1,4 dicarbonyl compounds, we may use the alpha beta unsaturated dicarbonyl compound, or we can use the alpha beta saturated dicarbonyl compounds. Look here. So this is alpha and this is beta. First carbon, second carbon, third carbon, and fourth carbon. So this is alpha beta unsaturated 1,4 dicarbonyl compound. Or we may use the saturated compound also. Look here. This is the 1,4 what is that 1,4 saturated and alpha beta, no? So alpha beta saturated 1,4 dicarbonyl compound. This is unsaturated and this is the saturated compound. Here when it is treated with the hydrazine, look here. Here to first of all, one water molecule goes outside. As a result, what happens? So here we get condenser product here. Then after one more condensation occurs and one more water molecule goes outside. Okay. And here, look here, when you are treating with the what is that the saturated compound with hydrazine, similar to this one, we are getting the saturated what is that hydrazine compound, pyridazine compound. One, two, three, 4, 5, and 6. So this is known as the 1,4 dihydropyridazine. And when it is treated with the bromine in the presence of acetic acid, we know very well that bromine is halogens are good oxidizing agents, no? So here this bromine oxidizes this one what is that 1,4 dihydropyridazine to the pyridozine. So now we get the 3,6 dimethyl pyridozine. Discuss about the third preparation method of the pyridazine, that is the 3+3 condensation method. In this method we use the cyclopropene. Look at this is a cyclopropene derivative. For convenience we are substituting R group. And when it is treated with the diazomethane formula is CH2N2, no? So this is diazomethane. And we can write the diazomethane like this. Okay, and we can write here plus. So here we get a what is that addition product, 6-membered addition product. So look here, we have to write R CH3 and CH3, okay, and N double bond N. But here 2 hydrogens are there, so here we put 1 hydrogen here. Okay, so here cyclation occurs, this bond breaks and electron pair will be shifted here, and this bond breaks here and electron pair will be shifted here, and this bond breaks and electron pair will be shifted here. As a result, we get this compound. Look here. So here this hydrogen comes here. As a result, we get this compound. Okay. This is dihydro 1,4 dihydropyrazine compound, pyridazine compound, and so look here, this ring opening occurs in the presence of acid or base. Now here dehydrogenation or aromatization takes place in the presence of oxidizing agent, that means oxidation. So if we oxidize this one, we get the pyridozine derivative. Or so here we would put one CH3 and another CH3 here. Okay, so that is the pyrodozine derivative, and this is the third preparation method. Okay, discuss about the fourth preparation method, that is by using the furanone derivative. So here we use the 3-furanone. Okay, look here, this is THF, tetrahydrofuran, and if we put one double bond here and another double bond here, that becomes the furan. But here we have to take the furanone, so this is a 3-furanone, and we have to take the 3-furanone derivative. So here we put one methyl group, and here we put the another methyl group, then it becomes as the 3,5 sorry, this is 2, no, so 2,5 dimethyl 3-furanone. Okay, so this is 2,5 dimethyl 3-furanone. It is treated with the benzene diazonium chloride. Look here, C6H5 N2 plus Cl minus. So we can write that as like this, N2 plus Cl minus, no. So as a result, what happens here, substitution at the second position takes place. As a result, we get this product. Look here, CH3, and here a diazo compound. So it is a coupling reaction. Look here, and we will write the one more CH3 here. Now ring opening occurs. As a result, what happens means, look here, so here ring opening occurs. As a result, we get this compound. Okay, so this is a hydrazone compound, no. So here it is 1, 2, 3, 4, and 5. So it is the monohydrazone it is the monohydrazone of 2, 3, 5 triketone. Triketone. This on further cyclization gives us the what is that pyridazine compound. Look here. Okay, and C double bond N, so C double bond N, C6H5, N C6H5, and what is that hydrogen? Look here, one hydrogen will be shifted here. As a result, this one becomes the OH, and one hydrogen from here goes outside in the form of water. So as a result, we get this compound, and its name is what is that pyridazine 4-one. So in phenyl or 1-phenyl, 2, 3, no? So 3 and 6. So in phenyl 3, 6 dimethyl 4 pyridazine 4-one. So this is from furanone derivative. Okay, na furanone derivative. So in the in this method, first of all, we treat the furanone derivative with the benzene diazonium chloride. Okay. We discuss about the chemical properties of the pyridazine. First of all, we discuss about the aromatic character. Pyridozine is less aromatic even than the pyridine, because in pyridazine, 2 electronegative nitrogen atoms are present on the adjacent positions. Okay. Due to this more electronegative nitrogen atoms, it becomes less aromatic than the pyridine also. Here in these resonance structures, we can see the appearance of positive charge on the carbon atoms. By looking at, we can say that pyridozine involves in the electrophilic substitution reactions with a less interest. Okay, then we go for the basic nature of the pyridozine. Here pyridozine is less basic than the pyridine. Look here, pKa value of the pyridine is 5.6 and pKa value of the pyridozine is 2.33, and we know very well that the basic strength is proportional to the pKa values. Okay, here in a pyridozine, 2 nitrogen atoms are present. So presence of one nitrogen atom reduces the basic nature of the other, that means the second nitrogen atom. As a result, pyridozine becomes less basic than the pyridine. Here now we look at some electrophilic substitution reactions. Here look here, in these resonance structures, we have observed that negative charge appears mainly on the nitrogen atom, no? So here pyridozine electrophile mainly substituted on the nitrogen atoms. Okay, na? And the carbon atoms of the pyridozine are electron deficient carbon atoms, so that's why generally electrophile will not be substituted on the carbon atoms of the pyridozine. So okay, when pyridozine is treated with the HCl, we get this pyridozinium chloride. So here H plus ion electrophile is substituted on the nitrogen. In the similar way, when it is treated with the methyl iodide, methyl electrophile is substituted on the nitrogen atom, and we get the N-methyl pyridozinium iodide. And when it is treated with the Oxidizing agents like hydrogen peroxide or peracid or trifluoroperoxyestic acid, we get the pyridazine N oxide. This is known as the pyridazine N oxide. Okay, and this is trialkyl oxonium fluoroborate, and look, when it is treated with the methyl, only one methyl group is substituted, only one nitrogen will be substituted with the methyl group. Okay na? But here two methyl groups are substituted on the two nitrogen atoms. Okay na? So here two nitrogen atoms are quaternized. Now we go for the nucleophilic substitution reactions. Okay, when this pyridozine is treated with the methyl magnesium iodide, here methyl group will be substituted on the fourth position. No, so look here, in a Grignard reagent, methyl alkyl group is a nucleophile. Okay na, CH3 minus. So this is nucleophile. So here in a pyridozine, nucleophiles are substituted either on the third position or on the fourth position. And when this pyridozine is treated with the butyl lithium, here N-butyl group is substituted on the third position. Here it is substituted on the fourth position, but here it is substituted on the third position. So it may be substituted at the third or fourth position. Okay. Now we discuss about the displacement reactions. Here this is 3-chloropyridazine. When this 3-chloropyridazine is treated with the phenyl acetonitrile, this is phenyl acetonitrile. Here this chlorine is substituted with this one. So as a result, what happens? We get the at the 3 position this group is there, and this group is known as the alpha cyanobenzyl. So we get the 3-alpha cyanobenzyl pyridozine. Here we can see one more reaction for the displacement reactions. Look here, 3,6 dichloropyridazine treated with the aniline derivative, and here the chlorine is substituted with this aniline derivative. Okay now. Next we go for some reduction reactions. When pyridozine is reduced with excess of lithium aluminum hydride, we get the hexahydropyridazine. So completely reduced pyridozine. And when it is reduced with the sodium and ethyl alcohol mixture, what is that? We get the completely reduced pyridozine. This is the 3,6 dimethyl pyridozine. This one is what is that? 1, 2, 3, 4. So, and look here at the third position we are having the methyl, third and fourth, 6th position. So it is known as 3,6 dimethyl tetrahydropyridazine. Like that we can give its name. Here the pyridozine shows this some cycloaddition reactions also. When this pyridozine is treated with the Malig anhydride, we get the 1:2 adduct product here. This is addition product. We call addition product as the adduct. So we get this adduct. Okay.